Well, thank you everyone, and welcome to another data science presentation of part of an ongoing series of talks that we're very excited about. My name is Russ Altman. I'm involved with the Biomedical Data Science Initiative and the Stanford Data Science Initiative. And I'm thrilled to introduce Caitlin Smallwood, Vice President of Science and Algorithms at Netflix, where she and her team are working on predictive models, algorithms, and experimentation science for all parts of the Netflix business. Now, if you've been following Netflix, that is a growing palette of activities, and therefore I'm sure very exciting. Caitlin herself specializes in analytics, recommendation systems, controlled experiments, product management, business intelligence, and data strategy. Other than that, not so much. She is a Stanford alum with a master's in operations research, and she did her BS in mathematics at William & Mary. So we're thrilled to have you today, and I'm going to take a moment to transfer the microphone because really you're here to hear her and not me. Thanks for coming.
So thank you. It's really great to be here. I'm probably going to stand like this so that that light's not quite in my face. And I'm thrilled to spend some time with you guys talking about one of my very favorite topics, data science, and especially how it's applied at Netflix, which has really been a highlight for me in my experiences with my career. So I'm going to try to mostly kind of touch on a number of different applications of data science at Netflix so that folks here who are considering careers in this field can kind of get a flavor of what this might look like in action. And I'll try to sprinkle in some of my own opinions and insights on what has made data science particularly successful for Netflix, because I do observe some different characteristics there than I've seen in some of the other places I've worked. So I'll assume that many of you have seen the Netflix product, but if you haven't, here's a screenshot of what you might get on the homepage if you were to visit the product. And Netflix is really trying to become the premier global internet streaming entertainment service. And we've been very excited about this expansion that we've done. In January, we really launched to many, many more new countries. And we're now almost global, save China, just the small country of China. But we're trying to get there. And it's been a super exciting journey to get into that space. We have more than 75 million members across the world today. And those members stream more than 125 million hours per day, which makes me a little bit sick, frankly, when I think about that at times. But it's just a phenomenal usage and engagement with the service. So it's a really fun space to work in. We do try to apply data science to all of our largest decisions and areas, and all forms of data science, lighter techniques as well as the deepest machine learning techniques. And we really try to keep an eye toward the major areas where we can have an impact. So we work on content programming decisions, marketing, and try to personalize even the marketing as we reach out to potential customers. Also on the streaming service, that's an amazing technical thing on its own, is how we deliver all this traffic around the internet at a really high quality, because we really want, when a customer clicks play, to have that experience just be shockingly smooth and easy, even under low bandwidth conditions, like the best that we could possibly make it. So there's actually quite a bit of science that goes behind that. And then, of course, the recommender system is the obvious big application that folks tend to think of when you think of data science at Netflix. And then our product launch decisions. So all of these are areas where we really invest a lot in data science. Today, I'm going to mostly talk about kind of three of these, but not necessarily in a succinct way. So we have a lot of data. We have probably all the kinds of data that you can imagine that we might collect and more. We have data about members, visitors. We have data about all the views and plays, the titles people watch, how long they spend watching them, the device they're on when they watch the titles, so that when my kids who are sitting here in the front to get an experience, when they watch something, they don't realize I can sneak into the Netflix systems and figure. No, I'm just kidding. Anyhow, no, we're very careful about privacy, so I actually can't do that technically. So anyhow, just a tremendous amount of data that we collect. And what I like to think about is really our most valuable data that's used over and over and over in all of our applications is really the member viewing data, because that data really captures human tastes in entertainment, right? And it's tough to wrap your head around tastes. They are so vast and different from person to person. One one way we can look at tastes across many ways that we do is studying these row labels. Netflix over the years has evolved a system for defining very specific row labels. Each of you, if you use Netflix, you'll see a different set of labels on your rows. And you'll see specific things like Girls' Night In and murder mysteries with a strong female lead or things like that are these very specific labels. And it's really fascinating to think about how those labels can capture human taste. So I decided to take a look into how many distinct labels we have at Netflix. And this is just one naive way, again, of kind of capturing human tastes. If we were to plot a distribution of those distinct labels names and plot them on a chart, it looks something like this. This is not even drawn to scale, and there are more than 50,000 distinct row names. And I didn't draw it to scale because I wanted you to see that there is a little bit of a head. And the types of things in the head are common genres like comedy, drama, action and adventure, that kind of thing. And then as you progress down the tail, you get into those more specific categories. Don't read anything into the specific titles. I was just trying to give you a flavor for what that category might include. But the point is that this tail just is incredibly long and varied. Humans would have a very hard time digesting this, as I mentioned. And one area where that's challenging for us is in the softer kinds of areas that Netflix is in, such as the content development, right? These very creative, human judgment-based experts in content and creation, that kind of area where you've got human decision-making going on rather than a machine making the decision. And so what do we do about this? How do we help inform these kinds of spaces with data science? This, by the way, has been an area for me in my career that's been more and more fascinating over time, because the hard problems where you get a clear dependent variable and you can study how things are related to that, it's wonderful technically. It's easier to put into place than something where you've got this mixture of the science with the human judgment. So I thought I'd just kind of share some of the things that we do to try to help inform the content space. And really it all comes to having tools at people's disposal that they can sort of play what-if games with or leverage the information that comes out of some algorithm or model to then inform their decision. And so one of the things we do is really try to understand the aspects of the tastes in the content. This is a different way of looking at taste than what I showed you before. This one, in fact, is using a fairly straightforward factor analysis technique to really pull out the unique components of people's tastes. And any one person is a blend of multiple types of tastes if you were to look at your viewing history, right? So you might watch some things that cluster together with these titles and some things that cluster together with those, and et cetera, across people. And so we can pull these out with an unsupervised techniques to try to understand these clusters. And then after the fact, we can put labels on them. Again, I want to distinguish this as very different than what I was showing before, because before we were starting with sort of tags that we have, that humans have tagged the titles and then kind of creating the row labels. In this situation, we're doing more of a bottom-up kind of clustering and then trying to understand what those clusters are and putting in labels on them so that we can discuss them more easily. This kind of thing helps in the content area so that they can design the catalog, right? When they're trying to look across our entire catalog, we want to really satisfy everyone's tastes, and we want to provide the variety that people want, and we also want to pay attention to things like how quickly do people churn through the content in the areas where they are excited about those kinds of shows and movies. So there's a lot of planning that has to go on to really keep the catalog robust in all these different areas. So this is a really great technique for them. Another thing is title-to-title similarity. Obviously, this is used in many ways across the industry. Nothing new at Netflix in terms of the techniques for coming up with the title-to-title similarity. We do have multiple title-to-title similarity algorithms at the company that we use for different applications, because the applications vary a bit. But here you can see, people who watch The Wedding Singer, what else do they watch? Then we could ask, people who watch The Wedding Singer and Jerry Maguire, what else do they watch? We could also ask Wedding Singer, and Batman Begins, what else do they watch, right? And being able to do this in a convenient way through a tool really lets you get a sense for a title. If you're on the creative team down in LA, it really helps you get a sense for kind of the audience for a title and what that title, who that title would appeal to, right? So this construct has been very helpful. And to make that a little more specific, it's really helpful with originals. Let's say it was a couple years ago and Netflix was thinking about investing in House of Cards as a new original title. And we're trying to understand among all our members, who's the audience for that? How big is that audience? What else do they watch? How can we think about the demand for this title? And as the person who reads the script and knows the talent involved in the project and all that kind of thing, you might be able to say to yourself ahead of time, like, oh, House of Cards, once it's produced, it's going to be a little bit like West Wing meets Breaking Bad. And if we can start there, we can then take advantage of all that viewing data, right? And we can say, well, what else, people who watch the West Wing and Breaking Bad, what else do they watch, right? Now we get a more complete picture of who this audience is in terms of the things that they might like. And that, in turn, enables us to estimate the audience size or to estimate what pocket of new tastes are we going to be able to satisfy potentially with this piece of content. Yeah, question?
These algorithms are good enough to expose on the user side for better searching. And you
Yeah.
might say, today I'm feeling like this movie that I watched a little while ago or something else. Can you show me other things that we have?
Yeah, the question is, are these algorithms good enough to expose in the end product? And the answer is yes. However, I'll get into in a little while here how we think about evolving the recommendation system and the things that are in the product. But I think what you're getting at is also a pet peeve of mine over the years, frankly, at Netflix, that I feel like our search, there's a space that to me as a customer is missing in the product, which is I can search for a specific thing and I can browse the recommendations, but I can't get into that in-between space where I want to kind of actively explore the catalog. And you're right that internally I get to use all these tools that help me explore the catalog, and I do sometimes find myself using them to find something to watch when I'm in a particular mood. So hopefully, we will get there in the product over time as we test more concepts. So let's see. The other thing we do for the content organization is this is one of the harder set of models that we have. We try to predict demand for a title that is not yet on the Netflix service. And the biggest application for this is really when we're planning to license a title from a studio or other entity, and we're trying to figure out how much we're willing to pay, right? And our content budgets are just crazy, the amount of money that Netflix spends on content. And so the dollars that we're wielding here is huge. And if we can make better decisions about the amount of money we're willing to spend on each title, that means we can be more efficient about that spending and get better content for all the members, right? So it's a super important problem, and it's a very hard problem. And we have a series of models, more than 100 models actually, because of some distinct aspects of some of the problems, but different varieties of models that try to predict how many viewing hours a title will get once we get it on Netflix. There are various scenarios. It's different for TV, as you can imagine, because you get hooked on a TV show and you watch episode after episode, right? Versus a movie, so that those worlds are kind of separate in our prediction problem. And then it's also different by region because the catalog is actually slightly different per region or very different for some of the regions at Netflix just because of the way the industry is set up and how difficult it is to license content around the world. And so we have a variety of models. We use a lot of gradient boosted decision trees in these models, a lot of regression, which is still awesome in many applications. And some of the data you can see here that's been effective for us for these models, certainly the viewing history, because we have all this history of titles that we've had over time at Netflix in combination with other titles that were in that particular country or catalog at that time. And that really is a lot of information. We have that similarity concept. There's a lot there that feeds into the models, the metadata, like the tags and the talent that's associated with the titles. And some external data sources are useful depending on the particular model area. But this is a huge area of investment for us over the years, and really fun and hard and exciting. I'll just note one sort of unsatisfying thing about this area is it's really difficult to track the success of these models because of the long time period. Because we make a prediction, then Netflix bids for the with the studio to try to get the content. Then it might be 6 months later we actually get the content on the site, and then we watch the viewing for a year before we kind of had the data point that is what our matches our prediction back then. By then the rest of the catalog is different, so it's not even really an apples to apples comparison. However, despite all those frustrations, we do try to log that stuff so that over time we can learn a little bit, whatever is possible for us to learn. But back to the recommender system, which is in some ways an easier problem because you've got the more absolute measurement that's available. The machine can handle this like incredible variety of data and all these intricate relationships between the signals in the data, which we have just a tremendous amount of fun with. And this is essentially how I think about our recommender system. We've got all these data inputs, a bunch of different algorithms, and then out comes the personalized user interface for each member. Now, I think that one thing, whenever any of us from Netflix come and give any kind of talk about the recommender system, we always feel a little bit badly that we can't really reveal exactly how it works in the level of detail that folks would probably love to hear. Like, okay, which exact technique are you using for ranking? Which exact technique are you using for the title-to-title similarity? And we just don't reveal that for competitive reasons. But I will say that there is no one silver bullet. There's no one magical algorithm that we have, or technique that we have found is far superior to all the rest. It's everything that people like you are studying and doing in your research. It depends on the application at hand. And there are many techniques that are just fantastic these days. So we actually have many algorithms that come together to form the recommender system. To make that a little more specific, just if you look at the diagram, the image on the right of the user interface, some of the specific rows have a specific algorithm just powering that particular row. So for example, I can see what I have there, my list, those are things I've added to my queue, and it will sort those in a particular way that has its own sorting mechanism based on how people tend to use their lists. The popular on Netflix also has its own algorithm behind it. We have a continue watching row that's trying to predict the probability that you'll keep watching something that you had already started. That has its own algorithm. So we have the sort of the core algorithms that power a lot of the recommender system. One of them is the page construction that figures out which rows to show and in which sequence to show those rows. And the other one is a ranking algorithm that for many but not all of the rows will rank the content in that row. So those are sort of two of the core ones, but then many other algorithms on the page. So
just one question about that.
Yeah.
Do the rows talk to each other so that you won't list a movie on both rows?
Do the rows talk to each other so that we won't list a movie on both rows? They do. Yes, we have kind of a separate layer to the product that looks across deduping and things like that. And not violating, sometimes there are also things we don't want to violate, like if we've got a bunch of kids content on the page, you don't want to put something really racy right next to it and things like that. So there's some stuff that goes on there too. That's a little more manual in nature. Yeah.
Curious how much the Netflix prize and all the work that went around it changed what you do internally, and do you view that as one way in which you develop new methods? Is that something, a model you're going to use?
Great questions. The questions about the Netflix prize from many years ago, when we open sourced a challenge to the community to come up with an algorithm to help produce recommendations based on the star ratings. And the specific goal of that challenge was, given a set of users and their star ratings for a set of titles, can you predict what they will rate something in the future that they haven't watched yet? And it was a great competition. We did get a lot out of that. And back then, we took that algorithm, and it was a core algorithm in the recommender system for several years. Since then, the system has evolved so much that it's really only a tiny sliver today of what the recommender system is. Again, we use many techniques, and we're constantly exploring more techniques. And the state of the recommender system is not stable for very long in any one state because we're constantly innovating on it, which I'm going to talk more about. But we do use just a whole host of techniques. And again, there are just so many high quality techniques these days. It's really fantastic. We also study many, many different signals as the variables that go into the models that we build. And the sort of intricacy of these inputs gets more and more minute over time. And it's fascinating to see that we can still discover new signals. Even after 10 years of innovation on the recommender system, we still discover new signals to add to the recommender system. So I started mentioning that it's always evolving, and this to me is something that's really interesting. So we always start with just like you would expect, right? Somebody has an idea like, oh, I can improve the ranking algorithm, and I have a specific technique I want to try in a way, or a different signal I want to add, or something like that. So they'll pull a training data set, build a model, just in the normal traditional sense, right? Build a model, and then study the offline metrics. And here's, and then after that, we're going to run an experiment if it looks promising. And the experiment will help us validate with members whether they actually found it to be something that was better than the incumbent. So I want to kind of walk through that process a little bit because it's been key to, I think, Netflix's success in this area. So here's an example where you've got 3 different variants that were built offline in a traditional modeling sense for constructing the home page. So picking the rows and sorting the rows. And this is just the output that for one member that algorithm might have given on a particular day. So this is the kind of offline results. If we were to run this model on Russ's user history, different varieties of this model would give those 3 outputs. And then what we would do in this case, for example, is we would say, okay, after I had made those recommendations, what you actually watched, but this is still in our historical data, it's not, we're not running an experiment here. This is just like our training data set, spit these out. Then we're going to look at the next day and what you watched. And let's say you watched Orange is the New Black, The Office, and what do I have there? Star Trek. So now I know you watched those 3 things. And now we can essentially try to compute a recall in terms of where on the row, or where in the page were you when you, would you have been had we recommended things in that order. And then we can study those recall curves, right? And we can look at the red line, which is the current existing algorithm, and what its recall would have been. And then we can look at these new varieties and see if they look any better, right? And we can see here on the darker blue that earlier on in the row depth, so earlier on in the page, higher up for the member, easier to find, the member would have found that title that they watched anyway. Now, of course, this is a bit flawed, right? It's a little bit circular because our training data is not based on these algorithms. So everything's a little bit wonky, but it still gives you something to go on. You can say, yeah, I'm observing something offline that may indicate an improvement. From there, if we've found an improvement, now the key thing is to really see if members think that's an improvement. And this has really been a core to our whole product improvement process over at least a decade at Netflix. And just a quick show of hands, how many are familiar with experimentation in general? A little more than half. I'll just quickly kind of review some of the core concept is you take members and you split them and you give them different product experiences at the same time. And you try to hold everything else equal about the product. You just change that one thing. So in that case, we would have just changed the variant of that one algorithm that the member would experience. And then you observe their behavior over a period of time. And then you measure what they're doing and the statistical differences between those behavioral metrics, right? And this really lets you see how did the algorithms really pan out. I'm gonna show an example of that in a second. So, but I like to kind of build the intuition around experimentation. I myself was sort of late to the game in experimentation in my career. It was not until I was at Netflix that I started really working on any kinds of projects that involved experimentation. And I'm a complete convert. I used to think, oh, this is sort of a boring field. It's so straightforward. You calculate a p-value, you run a statistic, and it's just, it naively felt boring to me. But I could not be more riveted by this space. It's really fascinating and deep. But the intuition is, this is an example of Amazon Kindle sales. And in the blue, you have one version of Amazon's website, and in the red, another version of Amazon's website. And you can see that soon after they launched website B, their Kindle sales rocketed up, right? So it would be easy to go like, oh, well, website B is much better than website A. But on that same day, it turns out that Oprah happened to mention something about Kindle being one of her favorite things, right? And now the problem is we don't know why. We don't know why the increase happened. Was it website B or was it Oprah? So this really is the crux of why experimentation is so very powerful if it's done well and correctly, right? Is it can really help you get at causality rather than correlation. All these amazing machine learning techniques and all this other stuff we do, while great, while awesome, I think that all that stuff's great, it still is essentially correlation. And an experiment will really let you get at the causality. So back to our example, had they been running both websites that whole time, we can now see that website A is actually doing a little bit better than website B, and now we might conclude that it was Oprah that caused that spike in Kindle sales. So that's the intuition. Now, for us at Netflix, in the world of algorithms, it's also important because members, the training data is all based on prior algorithms and what people have watched in the past, and that's not awesome. And then, of course, when you're trying to build a model, you need a sensitive, determined, variable that you're trying to model to. And it's harder for us to model to something like retention that's fairly insensitive than it is to the probability of playing a particular title. And so the problem itself is not quite the same. So these are things that really help us in the algorithm world. So there are many companies nowadays who do fantastic experimentation. I don't particularly believe that Netflix is better at experimentation than any other company. We're very rigorous about it. There are many companies that are rigorous about it. But it is a very unique thing among a smaller set of companies, I think, who really do it at scale. And I would definitely say we do it at scale. So every year we test at least 500 different unique algorithms. And we try to test them and set up the product from an engineering standpoint in a way that we can make the different algorithms independent from one another and draw conclusions about them so that we can get more testing done at the same time. So for example, the Netflix search, the member experience is a kind of a separate part, and the algorithm runs in a way that's independent from the other algorithms. And so we can run tests in the Netflix search algorithms at the same time as we run tests in other algorithms. So that's one piece of setting up testing at scale. Along the way, though, you also have to be really careful about conflicts, because you can imagine you might have two engineering teams building two different tests, and they think that they're not going to conflict with one another, but there's some member experience that really gets messed up, or subtle things that really screw up your ability to get a read on the test. So we do put a lot of energy into monitoring for conflicts. Let's go through a specific example of one experiment. It was sometime last year we launched a new row in the product called Trending Now, and we hadn't previously had that row. And the Trending Now is trying to do exactly what you would guess. It's trying to pick up on temporal trends that are going on in people's interests in the product. And before we actually just launched that in the product, we did all the things I've already described, right? We built models offline, and then we ran an experiment. So first, how did we explore the models offline? Well, there were many machine learning experts and others who had opinions and ideas and thoughts on how we might build such an algorithm. And so we came up with a test plan and exploration plan, and many, many people ended up working on this one test that we ended up running. And these are some of the things that varied by the different variations of the algorithm, right? So we wanted to test the presence versus the absence of this new row, the technique itself that was underlying the model, the parameters of that technique, like you can imagine, depending on the technique, different types of parameters, the time granularity, how temporal do we want to be? Do we want to be like this is trending now this hour or this day or this week? The specific signals that were variables in the model, and then the degree of personalization. Should we show the same trending now row to everybody, or should we have some degree of personalization in that row? So we constructed a test plan that had many different test cells that would cover a variety of these combinations. And then engineering teams and part of my group would go off and work hard for a while, like a month or sometimes 2 months, depending on how intense the algorithm is, working on actually building each of those variations of the model. And then, I can't stress enough, if you're in an environment like this, how hard you have to work to hold everything else constant besides the algorithm itself that you want to change. And for example, imagine we just inserted that trending now row. Now suddenly there are more rows on the page. And you know what? We're going to get more streaming hours when there are more rows on the page. Or it's going to do something to the streaming hours. And that's not because of the quality of the trending now row. It's just because you have another row, right? So you have to think about how are you going to set up the experiment to hold things constant. So all of this is actually a really big investment, and I think there are many companies and people I talk with at smaller companies who ache to do the kind of testing at scale that larger companies can do, but it's really tough without a massive investment. We have more than 100 people just working on these algorithms and this ongoing testing at Netflix. So it is a very, very large investment, which doesn't mean experimentation isn't worth it on a smaller scale too. It absolutely is, in my opinion. We have to think a lot about who to sample. And this is another thing I see when I hear about experiments at other companies that's easy to get wrong, because it feels so easy, you don't feel like you should really put any brain power toward it. But imagine like who should we really, this is a judgment call, right? Like who do we want to optimize the product for? Is it for new members? Is it for members who have been loyal and with Netflix for a long time? Is it for people on particular devices where we really think that should be a big investment for us? There are geographical considerations, and all of this impacts sample size opportunities and things like that as well. So we put a lot of thought into that. And here's an example of one test, results from one test. Don't try to study the details too much. Just green means there's a statistically significant positive impact, and red means statistically significant negative impact. And each of these blocks, these 6 blocks, are the same test. They're just the results on different populations from that slide I just showed you a minute ago. So you can see how dramatically different our decisions would be depending on the population that we choose. So it's a really critical decision to make sure that executives are aligned on and that people really believe that, yes, we're making our decisions based on the correct population for our application. We mostly lean toward prioritizing results from new members. And that's because they are not tainted, right? They don't have a previous experience with Netflix, and they're not reacting to a change effect. We think that they're representative of our future member base, and since we're still a largely growing company, rapidly growing on kind of the S curve of company's growth, we think we're not really flattening out yet. So we do think, we believe, it's a judgment call. And then they're more sensitive, right? When people start Netflix, they have a free trial for a month, and whatever that experience is in that first month is going to really make or break whether they stay with Netflix for a long time. So now we're ready to launch this Trending Now test. Oh yeah, question?
Do you mostly see a this population where people sign up and then commit, and others just sign up for a month and cancel? Or are there a lot, high percentage that come back and forth or join during holidays and then stop?
Yeah, how often do our members sign up and stay, or are they more flaky and they come in and out? So we have We do see that retention after the first month is very high and stable, like really long term. So the first month of retention is really the key signal for us on how well the product really resonated with someone. We do have a lot of folks who cancel and rejoin because we intentionally make it really easy to cancel. We don't want to like dupe anybody into using the service. So make it easy to cancel, easy to rejoin. And that's a behavior that we do see people. And sometimes people will do it. We try to measure if people are doing that for a particular show. Like, oh, we have the new season of Orange is the New Black. Are you rejoining just to watch that and then you leave? There's a little bit of that for really popular shows, but not enough to really make a material difference for us on our numbers. So now we're ready to launch this Trending Now test. And so what we do with new members is each time new members join, we have a service, a product internally that is then sampling and putting those members into a particular test cell. And because we're doing it as they're joining, it can take a couple weeks to get the sample built up for a particular test. So we'll do that, and then we separately and independently, we usually draw a sample from existing members because we do want to make sure, although we make our decisions on the new members, we want to make sure we're not harming or seeing any scary problems with the existing members. So that's typically what we do. And then we wait. And this is one area where I would say Netflix's experimentation is quite different from most other companies that I know of, in that we believe in the longer term metrics for a variety of reasons. And so we'll wait 2 or 3 months while an experiment bakes. And most people look at us like we're crazy. When they first join the company, almost everybody who's has some sort of quantitative background, when they first join the company, they go through this phase where they're like, you idiots, why are you waiting this long? Just measure the streaming hours in the first week or measure the click rates and you'll be done. But what we've learned is that because our core business metric is this monthly retention, and we've studied all these shorter term metrics and their relationships with retention, and while they are somewhat explanatory, they don't explain enough of the retention for us to really feel that we can rely on them. And in these experiments, sometimes you're finding these tiny differences and making decisions on these tiny differences. So it just doesn't really add up. And the other thing is with algorithms, the more you watch, the more the personalization really kicks in. So in that space in particular, we need to kind of get enough viewing history per member to really get a read on the results. In this experiment, here's an example of the kinds of data we look at. I didn't want to share the numbers, but each column there is a different test cell or a different variant of that algorithm, of that Trending Now algorithm. And then the rows here are different metrics that we look at. So retention, overall streaming hours, just the sum of someone's time spent streaming and watching things on Netflix. The homepage streaming hours, because the homepage captures a lot of recommendations. Discovery hours is a construct that we have because you might be continuing to watch something versus discovering a new title. And then specific to Trending Now, we would look at the take rate for that row and hours that were discovered on the Trending Now row. So those are some of the metrics. And then when we study these results, there's the statistics behind that, all the classic statistics. We do use a number of different methods, and there's a whole big world there. But there's also this subtle thing of really applying strong judgment when you're interpreting the results. We do look for patterns and consistency in a story that hangs together so that we're not basing our decisions on a noisy situation. Many of those algorithms that people explore offline in the machine learning, with the machine learning techniques and the modeling, they look really promising. But really, even after all those offline results that look great, when we test them, it's still a minority of them that show a win in the test. And this is the thing that we come back to in terms of our commitment to this kind of approach, that we really feel that this is what has helped us make strong decisions in the product. And also we love the fact that members have a vote in what ends up in the product. Why do I think there's a disparity between the offline results of a model and then the online experiment results? It's really a couple of things. One is that, as I was mentioning before, when you build a model offline, your dependent variable is typically something that's a shorter term thing that's specific to the algorithm you're building that's not quite the same thing as what you're trying to do with the overall product, right? Like you might build an algorithm to maximize the probability that a user will play something at the beginning of the row, right? And that's different from caring about retention, right? So some of it's that, and then the other is this correlation versus causation thing. Yeah.
Yeah, I don't know if you want to answer this now, but one of the things about these kind of tests is you're kind of doing like a little gradient descent, and you're kind of looking for local optima.
Yep.
And like if you think about something like simulated annealing, every now and then you might want to heat it up and redo everything, but that's very stressful, I'm sure, for everybody. So do you have, and then maybe you don't want to answer this yet, or we can talk about it later, but do you have ways to do a major change that is not just an incremental delta over your current performance? Or is that just too hard to imagine because of the kind of sunk cost of the current system?
Yeah, that's a great question. How do we handle, making sure we're not stuck in a local maximum? It's something we talk about a lot, and we try to encourage really big and bold tests rather than small incremental tests. We've longed for a long-term holdback where we freeze the product in a certain state and then a year later compare the unification of what the product is then to what it was. But we haven't had the stomach for that because that's so much engineering effort to maintain all these details of the product in its old state. So we haven't done that, but we on the analytics side, we crave that. But we mostly just lean toward bold experiments. And we're fortunate that, knock on wood, so far we're a successful company and able to take on the cost of this big investment. And so if somebody wants to come and do a major upheaval experiment, we will do it. We will do it. It just might take 6 months for the engineering teams to build it. Okay, I'm almost done. This just a quick, you were asking earlier about the Netflix prize. And this is just a super high level evolution of the system over years. The prize really used to be the core, the star ratings algorithm. And then we kind of had a phase where we were really trying to optimize our core ranking algorithm. And that was really awesome, made some huge strides on the ranking approaches. And then we really, just maybe 2 years ago, got into page optimization. Prior to that, like when we were kind of right here in our timeline, we had a template for the home page that said, first we'll show the popular on Netflix row, then we'll show 3 genre rows, and then we'll show a because you watched row, and then, a template that everybody had that same template, and we populated it in a personalized way. But now we've evolved to a hairier approach that has been, frankly, a little bit painful internally, but we've made big strides in the product. That's really trying to optimize the row order, and it'll change for you each time you visit the product. And then now we're kind of moving into this context-aware world, which is fascinating and also pretty hairy. We're trying to take into account your context, your mood, your device, time of day of week, if we can kind of infer which profile you're watching on in case you're not very good at selecting your profile, things like this that are about the context, right? And this we think will improve the recommender system further, but TBD. The last 2 slides, I just want to touch on a couple things about the culture that I think make a difference for us in data science. And one of them is just that data has always been at the company's core. And there's kind of an expectation around the company that everybody, no matter what their background is, during the course of, say, their first year at Netflix, they'll pick up and learn quite a bit about just data and how important it is. Everybody at Netflix, like pretty much everybody, I think, really understands correlation versus causation. Reed Hastings will jump in and educate people on the spot if they don't, things like that, right? And so it's really at the core and prioritized, which is just luck, right, for someone like me. There's also this one's really interesting, no real isolation of the data science function. It's not like despite my title and my, super awesome org that I get to work with every day, I don't feel accountable for 100% of what goes on at Netflix with the data or the algorithms, or even I don't even feel quite 100% accountable for the stuff coming out of my team, because the whole surrounding system contributes to the quality and to poking at results and trying to understand if there's a problem here or a problem there. People are contributing ideas from all around the company. And we have several teams at the company who are working on various aspects of data and data sciences. This executive commitment and participation is phenomenal. So we will have, every week, we have a 3-hour meeting with several C-level people at Netflix, a bunch of VPs at Netflix, and any level like at the company. But we will pour through these experiment results and ideas for where to take the product next, and the nuances of how the algorithms are interacting with one another and things like this. And so because of that, it's this ongoing participation and education that really helps maintain the priority and the attention. There's also a pretty strong expectation that surrounding teams will support the data needs, right? So if we need data logged, in other companies I worked at, you've had to like really sometimes pull teeth to get data logged, and that's really not the case. Everybody realizes like, oh, it's very important to get the proper data set up. And then culturally, we have a public culture deck that you can find on jobs.netflix.com that talks about this freedom and responsibility culture. And some of it directly, in my opinion, helps our data science practice. The high context sharing, where Netflix is very open and transparent with a lot of information internally, this really enables people to understand the business. And I'm sure you all know, like if you're gonna work on a problem, it's so easy to model the wrong thing if you don't get all the information about how it's going to be used and what are the decisions that are actually going to be made, et cetera, right? So that's really helpful. The strong talent that's encouraged to take risks and really be bold, that really helps us try very unique things, I think, that I haven't seen in other places where people are willing to really stick their neck out. The transparency and debate, like I already talked about, that's huge in terms of really catching bugs or finding problems or ferreting out issues that we might have in some future thing we're going to try. And then I think we have a lot of humility. I mean, we realize that many tests fail, and that's actually a great experience because you can have some hotshot machine learning person who like thinks that they are God's gift to humanity, who builds this amazing algorithm, and it is technically amazing. And then you run it in a test and it fails, and there is nothing like that to keep people like human and humble, and I really think that goes a long way for us. So with that, I don't know how we're doing on time, but if there are, oh good, we have 5 minutes. Any questions? Oh, thank you.
We do have time for questions.
Yes.
I have at least 3 questions I want to ask. I'll try 2 of them and see if you can.
Go for it.
The first one is, what's the rationale for the actual categories of movies? So, because our human pattern matching on top of the categories isn't necessarily reflective of the underlying data. So I wondered if you've done any kind of unsupervised approaches to thinking about categorizing, or whether it needs to be something that the user can understand. And then the second one is, how do you deal with this idea that people have a list of movies they think they should watch, and then they have the movies they actually watch? So I've never watched Schindler's List, which I feel I really should watch. And every time I pull up Netflix, I think I should watch it today, and then I choose Transformers or something. How do you deal with that?
Yeah. So your first question is about categorization and the unsupervised versus supervised kind of approaches. And we actually have, it's difficult to explain without being able to really get into the details, but we do use multiple varieties of classification. And all of the approaches you can probably think of in your head are somewhere living in the recommendation system. The tagging system in particular was derived years ago, and through similar process I described, experimentation, trying different labels out and seeing what resonated with people. But the way that those rows are populated is actually more the unsupervised approach. So it's a little tricky to describe in terms of the titles themselves that are in those rows versus the labels that come out in the user interface. But they're somewhat, they're not independent, but they're not completely joined at the head. They're not the same algorithm in one thing. So I don't know if that answers that question. And then what was your second question again?
Well, the idea about people listing the movies they feel.
Oh yes, the second question is, what about aspirational viewing? We all feel like we should watch these great documentaries that are educational. I made them watch a TED Talk the other night, and they're like, oh, don't make us watch another TED Talk. So there's the aspirational viewing, then what you actually do. So we want to accommodate people's interest in that kind of thing, and so the list feature where you can add things to your list really kind of takes care of that. And we do interestingly see that people pretty much don't really use those lists. People put things in that list that they think they want to watch or they should watch, and then what they actually watch in their next session, they search around or they browse around, they find something else to watch. So we sort of handle it that way. And yeah, it hasn't really been an issue. Yeah, question?
Yeah, I was really fascinated with your use of building predictive models, and you say sometimes the context changes, so you can't really go back and try to refine. But something like we're gonna invest $1 million or $10 million to do an original content. To me, there's more of a modern mind need to figure out how can we make our predictive models better. Have you built some way of like a feedback loop where you figure out ways of trying to refine some of your predictive models over time? Because you've got all the data and everything too. So.
Yes, we do have all the data, and so we do store our predictions at the point in time that they were used for a decision. And we have we're starting to get enough history that we have a little bit of data that we can look back and actually kind of study that accuracy. But there's still strides to be made even in the offline measurement of those models. And so we are constantly trying to evolve those models. It's just that unfortunately we can't like run an experiment to validate that the new version of the model is better. So we have to rely on those offline results more heavily. But we do constantly think about, okay, what else can we track? We try to actually track the content team's decisions too, which is a little trickier to get them to spend. It's like what you were talking to me earlier about, like how can we entice people to track stuff that will, in the end, really help them. But it's a pain in the butt, right, to sit there and say, oh, I decided on this original because I thought it would have global appeal, and I thought the talent would work well together, and that kind of thing. So, yes.
How do you guys deal with like the problem of kind of overfitting your data? So a lot of times if you train a model and then your training data is now influenced by the model you made because you recommended all these people, all these movies, so of course they're going to watch them, and so then it kind of like feedback on itself, so maybe you just overfit the data and now you've recommended people the same things.
Yep.
So how do you make sure that your model isn't influencing the new models that you're developing?
Yeah, perfect. So the overfitting problem, of course, is a classic problem that probably many of you, if you're studying this field or have studied that, or you will. And there, some things you can do in terms of the technique, but really what's more important is the judgment around formulating your training data set and then how you're going to use it afterward and what can you do to accommodate that. This is another reason why experimentation is really fantastic, right? So the experimentation saves us from situations where a model might have looked amazing, but it was really just an overfitting situation. And then when we test, and you can't necessarily prove that it was because of overfitting that the problem occurred, but it's one kind of safety guard in terms of how things end up in the product. Separately from that, we're fortunate that we have data that's changing enough over time that we can also try models on very different segments of time in the training data set, which can help. But then there's a lot of things just in the design of the model in terms of the number of variables and all that kind of stuff. Yes, Matt.
In terms of one of the things because using judgment versus also along with prediction, you guys have an experimentation and simplification. So part of the thing is you come up on a large menu, multiple screens, multiple work choices. We had an experience to say, it's 9 p.m., I think you'll watch one of these three things. If there's only 10 options, or it's mostly around a large number of options.
Is your question, do we test things that involve the time dimension, time of day?
Time dimension also, to me, sometimes the menus, whether it be on Netflix or any other service, the challenge of watching something is actually the number of options there.
Yes. Oh yes. So I think what you're asking is like humans kind of sometimes disintegrate from too much choice. Is that what you're getting at? Yes, I agree. And we have over time tested many different varieties of how many shows or movies we would show on one screen. And things like the row length when scrolling, even that kind of stuff, we've tested and tried to optimize the row length and the number of rows on the page that you can scroll to, and the box art size, how many things should we show you at once so that your brain isn't overwhelmed. But it's a fascinating area that I certainly don't feel like we've totally answered it and could, say write a paper on the optimal set of things to show someone, but we've gotten it to work in a pretty good state in the product through a number of different experiments.
I think we're going to have to stop here. Maybe Caitlin could stay a couple of minutes if you have another pressing question, but
Sure.
please join me in thanking her for great.
Thank you. Thank you.